Okay, question 2 on midterm number 3 goes like this. We have men's shirt sizes determined by their neck size. Okay, suppose that men's neck sizes are normally distributed with a mean of 15.7 and a standard deviation of 0.7 inch. Retailer has shirts in these sizes, and these sizes go with these neck sizes. Okay, because the retailer only stocks these 4 sizes, what proportion of customers will find the retailer doesn't carry any shirts in their sizes? So basically we're looking for customers whose necks are smaller than 14 or greater than 18. We're told that men's neck sizes are normally distributed with the mean and that standard deviation. So what we're looking for is the probability that any given man has a neck size of less than 14, and we'll add that to the probability that a man's neck size is greater than or equal to 18. I think I said 17 up there, I meant 18. Okay? That's it. Those are the probabilities. So let me just draw one picture. We'll be able to see both of them with that. The mean is 15.7. Sigma, what's the sigma of? It's of the population of men's, or the neck sizes of the population of men. We're looking for the area left of 4 and the area right of 18. Okay, now I could do this in 2 separate operations and add them together, or I could do the middle and then subtract it from 1. And I'll do it that way because it's going to be a little quicker. Okay, so what I need to do is look at the normal CDF from 14 to 18 with a mean of 15.7. Let me just check that. Yeah, means 15.7 and sigma is 0.7. So the probability of getting the correct shirt size is this. We'll subtract that from 1. Now, I'll get a negative. Probability is not negative. You guys understand why I did that, right? Okay. So the probability then is 0.0081. So 0.0081. That's the probability of not finding a shirt in your size. If we scroll down a bit, using the sketch of a normal curve, illustrate the proportion of men whose shirt size is medium. Calculate this proportion. Okay, it's basically the same distribution, same picture as what we did above. Medium sizes are from 15 to 16. So I'm looking for 15 to 16. And guys, what they look at on the AP test is that you're drawing your picture appropriately. If you put 15 and 16 over here, you're going to get it wrong. 15 can't be to the right of 15.7. So your picture has to be in the right context. Calculate the proportion. What's the proportion that a random man's neck is between 15 and 16? So we can go back to the calculator. I'll just use the same function as I did before. The normal CDF function, I'm going to change the 14 and 18 to 15 and 16, like that. And so the probability is 0.5072. So this probability is 0.5072. Okay, now, part 3, and you might very likely find a problem like this. The first 2 were normal. The last one is a binomial situation. We're going to pick 12 random people. What's the probability that exactly 4 of them will have size medium or request size medium? Okay? So basically, 4 or a medium is the success. What's the probability we'll get 4 mediums or 4 successes? Okay, this, if we look at X as being the number of medium necks, like that, we're looking for the probability X is equal to 4. Okay, well, X is binomial with n equal to 12. Probability of success is 0.5072. We got that from up here, from part B. And then we get the calculator out, and we go ahead and do this time a binom PDF, because we're looking only at exactly 4. So binom PDF, n is 12, P is 0.5072, and we're looking at exactly 4. And so this answer is 0.1139. 0.1139. And that is question 2. Okay, question 3 is the Venn diagram problem. So I'm going to start by drawing a Venn diagram, and I'm going to do it up here. Okay, I want to put a box, and then I'll put circles for A, B, and C like that. So there's A, there's B, there's C. The probability that you're not in A, not in B, and not in C is 25%. That means we can't be inside any of the circles if we're in this condition. So the 0.25 is going to go outside. We also know that the probability of being in A and B and C at the same time is 0.055. So 0.055 will be that inside middle probability. That's A and B and C all at the same time. Okay, we also know that A and C is 0.14. People are still making this mistake. 0.14 does not go here. You've got to do 0.14 minus 0.055. Okay, so 0.14 minus 0.055. That's equal to 0.085. So 0.085 goes here. Look, if you add these two together, they should equal the probability of A and C. And still, probably half the class is not doing this. Okay? We're going to keep doing it until you get it right. Probability of B and C is 0.08. Here's B and C. We've already got 0.055 accounted for. So that's going to be what's left over, 0.025. Okay, next part. We need to find A and B, but we don't have A and B here. We do have, however, the probability of B times the probability of A given B. That, by definition, is equal to the probability of A and B using the multiplication rule. 0.24 times 0.479 is equal to 0.11496. I did that on the calculator. Okay, 0.11496 goes here, but we've already accounted for 0.055 of that probability. So we need to subtract this from that, the 11496. If I do that, I get 0.05996. And I'm just going to put an arrow to it because I don't have enough room to write it there where you can see it. Okay, the rest of it's easy, guys. Probability of A is 0.55. How much of it do we have accounted for already? If you add these three up and subtract it from 0.55, what you have left over is 0.35004. You know that probability of B is 0.24. You've already got this much of that probability accounted for. Add these up, subtract it from 0.24, and what's left over is 0.10004. Okay, now all of these together have to add up to 1, right? We're just missing this. So if we add all these up and subtract it from 1, we find out the missing piece down here is 0.07496. And there's your Venn diagram. Okay, we'll do problem 4 on the next part. So go ahead and go to the next video.